Hey guys, my name's Hari. I'm a blockchain architect for QuickNode, and today I want to shed some light on one of the most critical job functions of blockchain development, data collection. So you can't always believe all the articles you read or the headlines you see. Blockchain development is actually on the rise, and the need for blockchain data is increasing rapidly. This graph shows the growth in blockchain data requests over the past 11 months, and it's actually increasing consistently. In fact, as one of many providers in the space, QuickNode alone has served over 500 billion data requests in the past couple months. So who's asking for this data? Well, it's coming from companies that have qualified a need to develop on a permissionless blockchain for their application. The blockchain development lifecycle are 4 questions or considerations that companies ask themselves before they go through the painstaking process of blockchain data collection. One question I hear a lot is, why do I need a blockchain? Doesn't a SQL database offer the same essential purpose, but with more efficient data collection? To answer these questions, we have to understand the characteristics of blockchains that make them so attractive to develop on as opposed to traditional database methodologies. These characteristics are decentralization, the lack of a governing authority to modify or change the data, security built into the architecture, data immutability, data integrity, and the transparency of activities. If companies find value in any of these 6 characteristics, they then ask the next question. Should I develop my application to work with a public blockchain, a private blockchain, or a combination of both? To answer this question, we have to understand the benefits of all 3. A public blockchain is a truly decentralized, democratized, authority-free operation. A private blockchain prioritizes efficiency and data immutability and is actually already being used in many enterprises today for accounting and financial purposes. A permission blockchain is essentially a network that lets anyone in as long as they go through a suitable identity check. This is useful for organizations that want to scale and provide financial and accounting transparency with their business partners. An example of this would be Walmart tracking the origin of their food sources for their suppliers. But the reason a lot of us are here today is because we work for companies or we're building projects on public blockchain protocols. And we're all attracted to the future of the internet that is going to be democratized, decentralized, and fully authority-free. So what are 3 considerations that we need to consider when a company first wants to develop on a public blockchain? Well, cost. How much is it going to cost to develop and maintain my application on this blockchain? Performance. Will this blockchain be able to provide the performance needed to provide a good experience to my end users? And developer adoption and user adoption. How many developers are building on this protocol? How many users are using this protocol? These are good indicators on if a protocol is going to be useful and successful. Today, 90% of companies that have already built on one public blockchain say they want to expand their project across multiple blockchains before the end of the year. And this takes us to the process of providing blockchain data from public blockchains to these companies that want to build. And it's not so easy. In fact, 68% of companies state DevOps or blockchain engineering as a constraint to get their companies off the ground. So what makes this process so hard? Well, this is what it looks like. And companies can actually host their own blockchain infrastructure to start a project or to test a proof of concept, but the issues come when they want to scale. Scale their SLAs to their customers, scale the support for chains they want, scale the underlying infrastructure that hosts the blockchain nodes, and scaling the blockchain nodes that they have to maintain, operate, and update on a daily ongoing basis. This is why many companies outsource this task to QuickNode or a blockchain data service provider like us. So how do we work? We're essentially a globally distributed network of blockchain nodes with the aim of providing blockchain data as fast as possible to users all across the world, regardless of where they are. And essentially how it works is whenever a user requests blockchain data, we send it to the closest geo-available blockchain node and then deliver it back to that user to provide the lowest level of latency. So our infrastructure and the way we have it set up provides companies that develop with us comfort to know that we have a highly available blockchain infrastructure. And this makes them feel comfortable to pass on our 99.9% uptime SLAs to their end users. When we talk about self-hosting, this is made even more complicated when companies want to provide support for multiple chains to their end users. And it's compounded when the companies are actually successful and require more blockchain infrastructure and throughput. Web3 data providers act as the cloud providers for these companies to make scaling of their blockchain infrastructure and support for multiple blockchain chains easy. We do all this while providing SLAs for very fast support response times to our customers, and we build security into every layer of this infrastructure operation. It's actually pretty awesome, but we can make it more efficient. These are some of the constraints that Web3 blockchain data providers are seeing today when we deliver data to our end customers. Cost, time, and engineering effort. From a cost perspective, sourcing data directly from the blockchain can get expensive. And this is true because even if two users are making the request for the same data, each of these requests have to be responded to individually. This leads to extra infrastructure and hardware overhead, which adds to costs. Time. Many of the applications being built on the blockchain today require blockchain data that dates all the way back to Genesis, or the creation of the first block. This can take anywhere from 2 to 6 months, depending on which public blockchain protocol the company is building on. This can halt developer development timelines, and it can stifle founders' ability to scale their operation quickly. And then there's engineering effort. When developers request data from our service, oftentimes they get data that they don't need along with the data that they do want. Then they have to go through something called post-processing, which is where they write scripts to extrapolate the exact data that their application needs so they can serve it to their end user. We're currently addressing all of these questions and constraints, and we plan to make all of these processes much easier for our customers. And we've actually already started. And here are some of the ways we're going to make this process easier. We're going to provide indexers. The idea here is to take all the blockchain data and dump it into an unstructured database and index the information so companies can pull the exact information that they want. Enhanced APIs. Companies that don't want to change the way that they gather data, we want to provide them with the very specific data they need so they don't have to go through the painstaking process of post-processing to get the exact information that they want. A blockchain database. We want to provide a continuously updating blockchain database to companies that only need read access to the blockchain so they can get the information they need cheaply and efficiently. And finally, collaboration. We want to work with all of the blockchain data providers in the Web3 space to accelerate down this path of data accessibility. And I want to highlight collaboration. We do want to work with all of these data providers. And what we've actually done is we've launched a marketplace to give our developers visibility to these data solution providers. And our idea is any of the companies that are developing on our platform, if they run into a hurdle that they can't solve with a QuickNode native solution, they can leverage one of our marketplace partners to solve that problem and continue to develop the next greatest application. And I want to take this back to the title of this presentation, which is Building and Owning the Future of the Internet. And I want to do this by explaining data accessibility in Web 2 versus Web 3. Currently, data is actually very easily accessible, but it's owned and gated by a few of the largest cloud providers and big tech giants in the world. This data is susceptible to being resold to third parties and can be censored or even permanently deleted if you don't meet standards and guidelines. In the Web 3 world, we have direct access to this data, and we have the ability to own our online personas and activities. But although this is an inherently better process and system, until we meet some of the constraints and solve them that I talked about previously, public blockchains won't be as widely adopted, and data won't be as easily accessible as in the world we see today. But this won't always be the case. Once we're able to provide easily accessible data, and we're able to provide data collaboration in Web 3 in the same format that we're able to do in Web 2, the inherent benefits of Web 3 will drive enhanced adoption of the current public blockchain protocols that companies are building their applications on already. Thank you for listening to me, guys. We're at the QuickNode booth, so if you guys want to come say hi afterwards and ask more questions, we'll be here all day. Thank you, guys.